Đâu rồi? Xin lỗi.
Can you hear me? Sorry.
Yeah.
Alright, so can you hear me? Sorry, the microphone doesn't work, so technician is coming. So in the meantime, we review together what we have learned from last week. So I already upload on Moodle lecture note and exercise. Did you get it? Yes. Okay. Did you prepare the exercise?
Yes.
Yes, very good. What is the tutor? Not today, right?
Yeah, not today.
Not today. So I have some few questions I take from the exercise list. So we do together atmospheric and this part the new lectures. Okay?
Okay.
So, be silent, please. And then we make quickly some quick tests. Just we take the exercise. That is for the first one. Maybe for the next one, I can get another. So let's try this question. Which answer you choose?
B. I chose B.
C.
B.
Okay. So
B.
if someone say A, 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 1, 2, 3, 4, 5, 6, 7, 8. Okay, thank you.
Thầy không biết là mày của nha. Mấy ngày này em bình thường hai giờ phải một lần trong học.
Silent, please. So A already some. So B. How about B? No one? No one. B. No one. So simple question, right? The first one is pretty simple. C. C. No?
Not about sound.
D. D. Oh. So very few people. We know, C, we know, and how about you have another answer? So who is A? Or you didn't do the exercise?
Ngược lại với
A.
Rồi.
All right.
ngược lại với
So the man walk 8 meters to the east, followed by another meter to the south. What is this? So we don't care the east, right? Because we care the north, south,
Yes.
and then he go to the south. The north is negative, backward, right? So the answer is A. This one.
Cái này
This one.
câu này không có.
So this type of question is the same format as in the midterm test and the final test. Alright? So what is your answer? Hey, who?
hai tính cho không phải làm sao cần để nó đi được.
Alright. So finish. Finish.
Càng tốt.
So who give answer A? A. 1, 2. A. Very little. 3. B. Who B? 1. B. 7. Sorry, what's your name? Han. Okay. The full name? Lên. Okay. B. 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 Good. B. What's your name? Trọng Nghĩa. Trọng Minh. So who is B? C. B. C. No one see. Just change the sign, right? Minus 5.33 and plus 5.3. Just a direction. See? No?
Wait.
B.
Vậy là đi.
B. And how about the others? No, A, B, C, D. That's silence. The correct answer is B. Okay? So, do you know how to do this?
Đúng. Để làm đúng gì.
Given that the pedal is leaking constant interval 5 seconds, calculate the average acceleration of the car. So, Mạnh Hà, can you tell me how to do, can you get the results?
First, I calculate the velocity of 3 stages. The first stage is straight, the right round. 0.5 is
So the times interval between 2 points here is 0.5 second, right? Okay. So can you speak louder?
Now we calculate the ATC 12 minus 4.
12? 4? What does it mean 12 for? So,
Đầu tiên là tính vận tốc của cái đoạn 6 m thì ta có là 12 m/giây.
so we calculate the average velocity for the first period. Here is V1 equal to 6, this is 6 meter divided by times 0.5. So he get 12 meter per second.
Đoạn thứ hai là 2/0,5.
This one, right. So between this is 0.5, and he can calculate the velocity during this period. So we assume that during the period of 4.7, the velocity of the car doesn't change, right? It's constant. It's constant between this point to the next point. But at this to the next is different. So here is V2 equal to 2 divided by 0.5. So this is 4 meter per second. And now he calculates the period from here to here. How long? 1, 2, 3, 4. 2 seconds. Right? 2 seconds from here to here. So the acceleration equal to V2, V1 divided by delta t equal to 4, 12 divided by 2, 2 or 1.5, 1.5, right? So if you calculate starting from here, 0.5, 1, 1.5 until here, the next, okay. So it's not 2 but 1.5 second. 1.5 second. So this minus 8, 1.5. So it's okay, everyone? Thank you, my hand. It's clear?
How can you find the 1.5 second?
1.5 second.
Vẫn lên kênh này.
So he start from this point.
Yes.
So next 0.5.
Yeah, 1.
Next
1.
1. And go to next
1.5.
1.5. And then finish, because for each this he's starting at the first point to the first next point. Okay?
Yes.
So from here to here is the same as average from here to here. Okay? So the shift is 0.5 second. Three intervals. Alright, clear? So three intervals between this period to this period. Agree?
Yeah.
Thank you. Any other question? Any other question? It's okay? Clear? So it's very simple, right? Alright. Next one. This one on the list or not? Exercise list or not? I forgot. minutes for this exercise. So remember this exercise. So I repeat, the midterm test and the final exam, I will take depend, but 50 to 60% the questions I have already given. Okay? So please do complete all the questions I give during the tutorials, exercise, and during the class. And then I will take at least 50% from that, exactly the same. To be sure that if you take part my course and do all the exercise, you will pass my course. Alright? So if you want to get the further more grade, then you need to do more. I will give more exercise from the new one, the new one, to distinguish many layers, right? To get 70%, 80%, 90%, and 100%. So I will have different. I will increase the difficulties and also new. All right? It's okay? So very few students cannot pass my course at all. But you have to do all the exercise I gave. Pay attention during my class, right? And then you will pass the course. And I don't have to meet you again next year. That's I don't want. So you have to answer? Hey, who? Minh Anh. Wow, a lot. 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow, very nice. Oh, so I need to go at the end to see some place. Student at the end. Can you see the slide from here? It's okay. So you get A answer? A? A? Yeah, raise your hand. No problem. If you don't, it doesn't matter. Right? No problem. As long as you think a little bit during my course, don't feel sleepy. A, okay. So many people. A, alright. Quite interesting. A, okay. B. B. Oh, still many B. Wow, it's interesting now. B. 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 Sorry. So many. This part. Okay, B. 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 Can you see the slide from here? Okay, very good. B. Wow, many B. Very good. B? No? Okay. Quite many people at this question B. How about C? C. 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 One. C. C. Okay. Only 1, 2. Very new face. Can you tell me what her name? Minh Đức. What? Minh Đức. Mạnh Đức. Minh Đức. Quý Đức. Minh Đức. Quý Đức. And Minh. So difficult to understand, but I try my best to remember your name. C. Mạch Hà, also C. All right, D. D, the last one. Last one. D. 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 Few people. D. Request, can you tell me what your name? Quang Minh. Quang Minh. Con là gì Minh nhỉ? Trọng Minh. Quang Minh. Oh. C, D, okay. Now, the right answer. Let's see who is the winner. A, B, or C, or D, right? Acceleration time graph. Acceleration time graph. Of a car moving toward north is shown below. Which of the following statement is true? A. The car achieved the maximum speed at the point X. You are A, Lâm?
Yes, I choose 8.
Okay, X. X is the maximum acceleration. But whether it's maximum velocity or not, speed. The car B. A car achieved the maximum speed at the point Y. And the car was at rest at the point Y. At the point Y, acceleration is 0. 0 means? Acceleration 0 means? Constant, right? Minh Anh, right. Minh Anh, what is your choice? A, right?
I'd rather not disclose that.
So at Y is 0 acceleration mean constant speed, not 0 speed, not 0 acceleration. At rest, 0 acceleration is exception, right? Maybe 0 acceleration, 0 velocity or constant velocity, you will get acceleration 0. Okay? D, the car was at rest at the point Y. Okay. The right answer is B. May I agree? I think you choose A, right?
Yeah, but like I'm changing.
B. But quite, I remember why so many people choose B. Yeah, good. Me, alright. So many other people at the end, this area choose B. Choose B, many people. Congratulations. And now I will explain.
Đi xe nhiều thì biết.
Okay, look at. So this the graph of the acceleration versus the times. So for example, it's starting from 0. Acceleration is 0. The car, firstly, at this point, is moving with a constant velocity. And now acceleration increase. And A is a positive. Means V increase. Okay? So the definition is acceleration is equal to delta V by delta T. A positive means V increase. Do you agree? So at this point, constant velocity, and then it increase the velocity, increase the velocity, increase the velocity. Still A is still positive. And how about here? Still positive, right?
Yes.
So velocity continue increasing, right? I remember you choose the right answer, right? Việt Long. So here, the acceleration is still positive. So velocity increase until here. It is constant velocity. So if I plot the velocity, I said velocity is this line, okay? So it increase until the y it gets a constant. And now if go next, acceleration is negative. So the velocity is decrease. Decrease go down, right? Decrease until this point, okay? Decrease. Until this point, it gets constant. Okay? So, where is the maximum speed? This point. Agree? So it's y. And the answer is B. Agree? Agree? Okay? So be careful. Look at the acceleration time graph. And then we'll talk about the speed, not acceleration. It's okay? Alright. One more. Speed time graph shown below. When will the car meet? Assuming that they start from the same point. Starting from the same point. Okay?
Cái này khó một xíu. Thầy
Finish? Okay. This one, all the exercises. This one is all the exercises or not? No?
bán cám hộ mình chặn lại cái ổ.
Alright. So take into account and then I will take the midterms or final test. I'm examining you. At least 50% of the question from the list I already gave you. Okay? To be sure that you know, to be sure that you pass marks, you do all the exercises. Is it okay?
sang kia.
Quay một lúc thì nó lại tiêu.
So I don't know how about other
Tiêu
course,
còn
but my course,
tiêu mất 40%.
I promise I give you at least 50% of the question. I already gave you in advance to the midterms and final test. But I will take randomly. Okay? Randomly. I assume you do all of them so that no one stay for the next year or do the retake again. Maybe similar for other course, right? Hopefully. Okay. Hey. Finish? Hey. No one? No one? No one? Not yet finished or no one? Hey. No one, hey. B.
Tôi đồng ý.
Con tên gì nào? Nữ. Như. Okay, thank you. B. Good. But still ready. B. B. Okay. B. B. Việt. À. Your name? Đăng Duy, okay. Việt Long. Bí. Hà. Bí. Ôi, nhớ một số bạn ngồi sau nhưng không những bạn ngồi trước, còn ngồi sau cô không biết tên. Con cho đến. Khoa, anh Khoa. Khoa. Ok. Mạnh Cường. Thank you. B, ok. C. C. Lâm không thể trả lời câu hỏi nào nhỉ?
Cái đoạn này con tìm được rồi.
Câu này tìm phải. C. Đâu ạ? D. D. Hôm nay học lại cấp 3 để có vẻ không dễ lắm nhỉ? Ta học hết ở cấp 3 rồi mà nhỉ? Đúng không?
Không nhiều.
Nhưng mà cấp 3 học kiểu khác à? Nên vẫn học kiểu này chứ nhỉ?
Kiểu khác.
Kiểu khác à?
Và học tiếng Việt.
Cấp 3 học kiểu gì? Cái đấy cấp 3 mà.
Cấp 3 học tiếng Việt.
The difficulties is language. That is also D, right? C, no, D. D. No? Cô này Minh Anh tìm rồi à? D. D, D. D. So, more number for the answer B, right? B. So let me check the results. I don't remember this. I have to check.
B.
B.
Yeah, random đúng rồi.
B. Congratulations. So it means that the number student give the good answer is the most for the B, so it's very good. Okay? So it means that you follow very well. Not very well. well, but I mean, at least I'm happy. Other than more people for A and no one for B is the best. But if I make the shape, okay, B is the maximum, right? Number of students. So in this sense, I'm happy. Alright, congratulations. I remember, yes, I remember Đức. And Đức and An is, and many others. And also Quang, yeah, you give the right answer, right? So I can remember morning. So now I explain why we choose B. So Minh Đức, can you explain why you choose B? Minh Đức, can you explain your answers? Minh Đức, sorry.
Alo.
Bạn là Minh Đức nhỉ? Hình như bạn đâu đây à? Minh Đức. Okay, thank you. Can you answer why B?
Following the graph, I can calculate the acceleration of A and car B.
Acceleration of car B and car A.
Yes, A1 is equal to 3.4 and A2 is equal to 3.
So A1 is where? This point?
No, it's
this point?
velocity
0. A is this line, right?
Yeah.
This is the velocity 0?
Yeah.
And here?
Is the velocity of 4 seconds.
4 seconds and get 12.
Yeah.
So you can get the acceleration.
Yeah.
Right. Acceleration of car A equal to
12 minus 0 and
divide
by 4.
Yeah. Or you can calculate the tangent of this angle. So this divided by this 12, 4. This 3 meters per second square.
Yes. And also I
Acceleration of B go from here
to
to here. So actually this angle. Okay?
equal to
Tan of this angle equal to this divided by this. And how much this? 6 minus 3.
yes.
6 minus 3 over 4. So it's 3 by 4.575 meters per second square.
Yes.
Alright. And now you what they ask the question? They start at the same points OX. They start from here. And they go A and B go. Assuming that they meet at M.
Yes.
Alright, so what you calculate? Displacement or?
When the two can be x A equal to x B
Right.
equal and it meet at M, so I can have a
Displacement.
Yeah, displacement.
Yeah, the displacement at M of A equal to displacement at M of the car B. And then they meet. And then this guy, you have XAM equal to
3
V0. No, 0. 0 T plus A T squared divided by 2
Yes.
equal to 1.5 T squared. And XM of the car B equal to 3. Initial velocity is 3. Very good. T plus AB T squared by 2 equal to 3T plus
This divided by 2 is 0, 3, 7, 5. Alright, t
T
square.
square.
And then you balance xm and xen.
And I use my calculator to solve it.
Okay, t square equal to 3t plus 75t square. And from this equation you can get two solutions. Right? T equal to 0 and t equal to 2.7 seconds. So how about this solution? Initial starting place.
Starting place.
Right, very good. So after starting place, they meet the first time. And after 2.7 seconds, they meet again. Right. Thank you very much. We do? Is it clear, everyone? Do you want to try one more? I think I have the last one. Okay, let's do one more, the last one. This another thing.
Work following the chorus. Displacement time.
They give the velocity time graph of the moving object is shown. Which of the following is the corresponding displacement time graph?
Đoạn cuối hơi chậm.
A, B, C, or D. Finger in the D. So who say A? A? Lâm, do you understand the previous one? Bài chưa hiểu chưa? Okay. A. No one? A. A. 1, 2, 1, 2, 3. I forgot your name, but I remember I already asked. Đăng. Gì Đăng? Hải Đăng. A. You, your name? Thanh Tùng. Hải Đăng, Thanh Tùng, okay. A. Your name? I think I asked your name once, but sorry, I forgot. Vinh. Vinh, maybe I didn't ask it. Chưa hỏi lần nào. Tại vì cô có tận 2 lớp không nên cô. Rồi con thì 2 lớp, mỗi lớp 350. Cô nhầm, thỉnh thoảng nhầm. Ấy. Ấy. Okay. A. A. Your name? Nicole. Okay. Nicole trùng tên với thầy Khôi. Hải Khôi. Okay. Đi. Wow. So many. Okay. Long đi. How about A. Đức. A. Vinh. Now B. 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 Bạn đứng ở bên cạnh đây đi con nhỉ? Nhi. Gì Nhi? Mai Nhi. Mai Nhi. Ok. Tên hay tên đẹp nè. Mai Nhi. Alright. Many people B. Wow. Many people B. Okay. Good.
Đoạn bóc.
Okay. Good. Con tên gì? Khánh Linh. Okay. Alright. B. lot. C. C. À, C. 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 Con nhớ khá là nhiều, con chưa biết tên con.
Exeter.
Quang Minh. À. Quang Minh này. Nhiều bạn Minh nhỉ? Quang Minh này.
Exeter.
C.
Em là con đường ấy.
Con tên gì Minh? Minh nhỉ? Trọng Minh đúng không? Quang Minh. D. Last one. À, Quang. D. D. Hải Đăng. D. D. An Đức. Cô biết tên con thế nào? Con tên gì nào? Hiếu. Trung Hiếu. Ok. Đi. Quang đi. Ok. Thank you. Check. Lesson. I forgot it, so let's say. What is it?
Sao mơ thế?
B, right?
Có cái nào?
Can you see the solution? B, right? I don't
Bạn một rồi.
It look like a
Let's B. Okay, let's see. Let's do this. So the velocity positive and it increasing. So the velocity changes. And then the displacement time graph is a curve or the straight line?
Straight line.
Curve, right? Curve and then this increasing. Curve increasing, you have this one okay, right? This one okay, right? And also this one okay. And this one quite okay. Then this one is also okay. And from here and then velocity constant means straight. Okay? Straight line. So A is okay, right? A is straight line. Good. This one is straight line or not? How about this guy? Straight line. And this also straight, right? Straight line. It's okay. 4, it's okay. Now, velocity decrease. Velocity decrease, but positive. So how about the displacement? No. That V equal to delta x by delta t. If is a positive, you have still displacement increase. No increase. Do you agree? Velocity decrease not means that the displacement decrease. Do you agree? The velocity negative, then it's decrease. But it decrease but still positive. So it's increase. But increase slowly. Right? Before it's increase very fast. But then it's increase slow. But no mean it's decrease. Do you agree? Because the velocity is still positive. Oh, didn't change direction, right? Still keeping the same direction. So, let's see. This guy decrease. So, no. This one decrease. No. This one also decrease. No. Okay? So So the remaining is only this one. It increase but very, very slowly. This one. It increase slowly. Alright. Cô thu nhỏ để con xin để đi lại. Thực ra cái hình này nhìn hơi khó nhưng mà ta loại trừ ba cái thằng này suy đạn này. Đúng không? Nó bởi vì nó tăng rất là nhỏ. Nhìn thấy gần như là đường thẳng. Ok. Tức là cái đường này ấy là ban đầu nó hơi cong cong lên này. Sau này nó thẳng này. Sau này nó tăng từ từ đi lên. Được chưa? Ok? Good. So we finish. Sorry today we take quite times for the technician problem. So now we start the lectures.
Yeah.
So, okay. Good. Okay, so previous class we stopped here. Did you do this exercise?
Yeah.
And you are okay?
Yeah.
Alright, so we go next. Thank you, very good. So we don't have to check this, okay? Easy. Because we already passing through several questions. So now we move to the next part, that is a free fall under gravity. Okay? Free fall under gravity. What does it mean? Free. The jaw. But why the jaw? Yes. I have the objects. Right? If I release it, it's falling down vertically. Okay? Right?
Yes.
It has this motion because there is an attractive force between the center of the earth and this one. It attracts, and our earth is spherical. Why is it vertical? Because, so actually, you okay? Can you see the slide? So the earth, for example, I have the surface, the earth is like this, it's a spherical, right? The center of the earth is here. And we are on the very near surface of the earth, on the surface of the earth. So for example, you are here. And then there's attractive force between this mass and the center of the earth. So the force is connecting between these 2 points. And attractive, the direction is like this. This M, G, where G is free fall acceleration or gravitational acceleration. And then you see that because our Earth is the sphere and the radius of the Earth is very, very big comparing to the side, our side. That is why around here we see flat, right? You see it's flat. You see quite flat. So after many in the many years ago, people cannot understand, believe that our Earth isn't sphere. Because everybody see flat. So even people think about have the flat form, and there's a square instead of square. That is why we have bánh chưng, right?
Yeah.
That is a square because people cannot believe it's curved. Why we see it's flat? Right. Because the Earth is too big. It is too big, and the radius is too big. And then our movement is short, very short compared to the radius of the Earth. So that very locally around the point on the surface of the Earth, we see it's flat. Agree? Good. So now you understand why it's flat. For example, you have two circles. It's a very small circle. And you are moving around here. You see the curve, but now you have very big, very, very big circle. So you move around very small on the surface. You see this quite flat. And this surface is a tangent, right? Tangent to the surface. So here is the Earth. So actually we see that somehow we are moving on the surface tangent to the Earth at this point. And then this one is a radius. So this one is a perpendicular. Okay? And this point, for example, another person at another place. They are in United States, right? So they are here. We are here. Our friend is here. So the attractive force between the center of the Earth is like this. And he is on the surface, he is like this. And he still sees. Gravitational force is perpendicular to the surface. We are standing. Right? This perpendicular to the surface, we are standing. And then we say that the direction of the acceleration is vertically downwards. Right? That is why. And everywhere on the Earth, the gravitational force having the direction vertically downwards. Even they are in a different place. And even the Earth's surface of the Earth is a surface, not flat. But the direction is a radius direction. And it's always perpendicular to the tangents of the surface at each point. And everybody moves around that point locally, right? It's a very short distance. For example, you travel, you know who know the radius of the Earth? As I remember, I'm not very sure, but I remember the power, 10 to 6 meters. So it's about some thousand kilometers. 3.6 or something. I don't remember which Google, right? 3.6 thousand kilometers, something like that. So you can imagine the radius, how big it is. And the distance from Hanoi to Ho Chi Minh City by flight, 2,000, something like that. So less than the radius. So for the movement, we are walking around, play football, some 10 kilometers. something like this. So it's very, very small comparing to the radius. And then that is why you see the surface on the earth is flat. Okay? Alright. Because many people ask the question, and then we should understand. Maybe when you go back home and your parents, you say, Mama, this the earth is a square, right? It's a circle, right? It's curved. So your mom said that no, I see it's flat. It's crazy. So and then you can explain. And also, we are on the 8th floor, right? And some people on the ground. But we see it's the same because the distance is very, very small compared to the radius of the earth. So we neglect the height until even 100 floor is no problem. Okay? Comparing to the radius of the earth is a few thousands kilometers. Okay? So this 5th floor or 20 floor, 100 is trivial. So you see the same. And then the same value of the gravitational acceleration. And it's called free because, do you know why it's called free? For is understand, it's falling. It's falling. But why free? Why the name is free? Nothing affects except gravity of the earth. Very good. Free means nothing affects this motion except the attractive force of the earth. So you neglect the air resistance, for example, right? And if like, for example, you hit it. Okay? So you release it free. It's free, right? You don't touch it anymore. And it's falling down. And neglect the air resistance and any effect around, for example, we have a very very strongly make the motion. So this, maybe it flies like this. So we don't consider these things. So free means only gravitational force acting on the objects. Okay? That's the first one. So because you are at the university level, so I give you the tip when you learn something. When you meet the new concept, first you try to understand the name. Because the name reflects the properties of this concept. Okay? It's not trivial, the name. The name reflects something. And then if you understand it, and then you just remember the name and not anything else. Right? But also you need to understand why they call this name but not other name. That is the question. And then if you answer this kind of question, you understand very well the concept you want to do. Okay? That is my advice after many years. So you learn in a short time and really understand the thing. Physics and other science. First, and then, okay? So the gravitational force of the earth pulls all the objects towards the center of the earth. And the body is a free fall motion if it moves under the influence of the earth's gravity. Alright. And then we really neglect or without air resistance, body free fall has acceleration known as acceleration of free fall, g. And g is a constant for all the objects free fall. If you are free fall or the chalk is a free fall, anything having the same. And you are here free fall and someone else on the lower and other place in Saigon or having the same free fall acceleration. Assume that. Doesn't require all the position. Doesn't depend on the height. doesn't depend on the mass of the object. Okay? Of course, when you learn more details, you will know that the value of G also depends on the position of the Earth, because the Earth we assume is a sphere, but not really sphere. Right? First, it's not smooth. And the density of the Earth is not the same everywhere. Right? So, if you look very, very deeply and very details, the value G is different for the different places. For example, in Hanoi, it's some value, in Chapa, some value, in Ho Chi Minh, some value, or other countries, they have different value. But the difference is very, very small. And in our frame, we different this difference. And we assume that in our course, we assume that G is a constant for all the position, for all the mass, for U, is the same G, okay? And the same for all the height near the surface of the Earth. It's okay? And the value of G can be measured by its parameters. And they can measure it at this value. And the unit is the unit of the acceleration, right? So when because we have some technician problems, so we go a bit faster. All right. So you are clear the gravitational free-fall motion. I have the question is get the velocity time graph and distance time graph for the body under free-fall from rest. So I leave this question for you to do at home. And maybe next class I will ask you to show the results. Is it okay? Fine? And then I can skip this part, this slide. I will post my slide on Moodle. And then you remember to do this one, and next one you show me the results. And we split together like that. Great? Okay. And the same thing, but for the project vertically upwards. Project upwards. Free fall downward and upward. In this case is a free fall motion. So remember, free fall motion is falling. Going down is falling, right? But free motion, something you pull it up and go down again. So in this case, for going up, still acceleration is the force, only the gravitation. So we have free, not falling but falling up. And then it's falling, but initially it's going up a little bit and then it's down. So in this case, you still call it a free fall motion. So it's vertical. Now, so free fall motion, you will neglect the air resistance. Alright? But now, how about the case? If you don't neglect it. So, if a chalk is falling down, you neglect the air resistance, is okay, reasonable. But now you have a paper. And it's free fall. And resistance is important, right? It makes the paper is going like this, and then going down. Right? So all you have a bubble is going down. So in this case, air resistance is important. So we will hear the case. If you have air resistance, what happens? So free fall motion. First consider the free fall motion. If I consider the object is moving vertically, this is a free fall. Here, air is starting the same point. And example, if I look at the velocity of the free fall motion, initially both case is a v0. So to be simple, I assume that g is equal to 10 meter per second squared. So g equal to 10 meter per second squared, what does it mean? If after 1 second, what is the velocity of the free fall motion? 10. Very good. 10. So another one question, another second, the velocity become 20. Another second, the velocity. So it increases every second 10 meter per second. So 4 seconds you have 45. Second you have 50. 6 seconds you have 60. 7 you have 70, and so on. It increases. So the shape, if we make the V depend on t, so it increases linearly. Agree? With the angle here is tan alpha equal to 10. Agree? So here is a free fall motion. Now you have air resistance. So the air resistance acting on the object is having these properties. Air resistance, when object falls through the air, it experiences air resistance which opposes its motion. Oppose. And the air resistance having these properties. If the velocity of the object is 0, you have no air resistance. Okay? So at this point, V0, no air resistance. But when the velocity increases, air resistance also increases. So air resistance increase if the velocity of the object is increased. Okay? So here you see velocity is increase. So the air resistance increase. Increase means after 1 second. How about the velocity? Not 10. That's, for example, 8 meters per second. And then it still increase. And then air resistance increase. So after 2 seconds, it's not 12. Here it's not 10, but it's maybe less. The distance here is 8, but the distance here may be 6. So maybe here is 14. Okay? The difference here is 6. The gap here is 8, but the gap here is more closer because the air resistance also increasing. So air resistance increasing means the gap, the changing of the velocity is less because the acceleration gravitational here, the air resistance is going up, right? Because it's opposed, making the velocity decrease. But this one is bigger, so the velocity of the object is still increased, but increase slower. comparing to the free flow motion. Agree? Because these guys oppose. So if I call the acceleration total, it should equal to g minus a of the air. Agree? So when the velocity of the object increase, a here is not constant, but a here is also increased. So if a increase, a total is decreasing. It's decreasing. A total decreasing means the gap A total here is equal to delta V over delta T. If this decrease, this on decrease. So delta V here is 8, delta V here is 6. Maybe delta V here is 4. So 4, you have 18. And then maybe here is a 2, you have 20. And even here, if it still increase until it gets the value of G. Until A equal to G. So what is A total? Equal to 0. And when A total go to 0 means, right, delta V is 0 and the velocity is constant. So until here, it get 20, okay? It cannot increase anymore. But also not decrease. No increase, no decrease, that's constant. So, in this case, you see, after 4 seconds, right? 4 seconds. So the free fall motion is here. 40. But that guy is a 20 is here. So it increase until this point it gets constant. Okay? This is the shape of the velocity time graph in case of air resistance. And the value 20 here is called terminal velocity. And the terminal velocity is constant. Okay? That is a free fall motion under the air resistance. So, for an object which released from rest and fall in air, initially its velocity increase. As the velocity increase, the air resistance also increase. The resultant acceleration of the object decrease, a total decrease, right? Finally, the acceleration becomes zero, and it falls at the constant velocity known as terminal velocity. Is it clear? Okay, so break 10 minutes. Sorry, take break 10 minutes.
nữa này.
Đánh lại hai lần đéo luôn được luôn. Đâu rồi? Đâu rồi?
Bán luôn. Trận đấy mày biết mày có gì để mày cứu được trận đấy không? Trận đấy mày chỉ có mấy lần đi xin đặc biệt mày cứu được không? Đồ ấy để nó đá hết rồi.
Thì đầu tí luôn nó sang con bờ.
Trước mới chơi có quả gì á? Có mấy con này là có hình như này đấy. Nhìn lỗi như vậy rồi. À thế à? Ngon thế. Bây giờ thì còn bắt đi.
Xe đấy nó xe lên xịn vào mày đây chẳng
Uầy, thế mày cũng đừng thế đâu. Ngon.
đánh Aurelia Sony.
Đây. Nó tí lớn thử.
Phép à?
Nó tí lớn thử rồi.
Con gì phép đầu game mày? Tao đánh thử Aurelia Sony.
Đấy thì nó được.
Tao đéo biết chơi. Chơi chết chịu.
Độ chết người. Chết người.
Chưa chơi phải lúc
Cái trước cái trước cái khoảng đầu đi xong rồi cái cứ bạt vào cái choáng ở trong một cái đầu ấy.
Các bạn nhớ thì con này là con tinh cực ba con này quay
Mẹ này ví dụ mẹ đầu game mày đè được nó chậm luôn. Mày cấp 1 mày đè được nó chậm. Từ cấp 1 đến cấp 3 là mày có cái tinh trùng không mày cứ quay cấp 2 cấp 1 cấp 2 cấp 3 cấp 3 một cái.
Quý Long thực sự. Mấy thằng đánh con này âm binh lắm rồi.
Người ta định này. Ở trên đó ta để nhầm nó cái thư đó. Ta tập nhầm thư đó rồi.
mẹ cái đám đi trước mà
Ta tập nhầm cái thư đó. Thôi. Ôi rồi bạn ơi. Ôi giời, chậm quá đi vừa xe này. Vừa xe chậm quá.
Tao không đuổi kịp quả cầu của tao.
Tất nhiên rồi.
Đúng không chơi bao giờ đâu.
Đúng rồi, các bạn phải may là tao vẫn phải trừng phạt đấy.
Tao né nó kiểu gì mấy quả cầu không dính nó.
Mày phải đi ra chứ, từng lần đấy cứ đứng gần mà nói tấm cho vào đầu.
Cầu béo.
Ô cái gì đấy? Sao anh Hoàng Kim Suối? Mày đúng cái tên luôn đấy.
Đấy rồi.
Anh Hoàng, anh Huy Kim Suối.
Tao có vòng to.
Anh Huy Chín Suối ơi. Anh Huy Chín Suối, anh mất quỷ
con này đánh giải trí các bạn, về cái chị bạn. Ui giời, đánh rồi.
Ôi giời. Máu con gì.
Tí thì nó đánh cắt đâu.
Mẹ con đi lên được.
Nghi đây. Câu khổng lồ. Dừng lại đi. Sao còn kéo dừng? Sao chiều 3 của nó hồi đâu?
Mình nghĩ là cái chiêu 3 là chiêu để bay để ram quanh mát để mấy con cái bao đi linh tinh à.
Tao đi lên mình giữ nhanh.
Đây, tao lên. Ôi giời. Đây. Né đi. Ôi tôi biết. Ôi bạn ơi, làm gì đấy?
Ơ kìa, cạnh chói con lính.
Thì cái con rùa này lách tao còn kéo điểm.
À, béo rồi.
Kìa.
Phổi ra.
Chết đấy nha.
Con này vừa tốn mana ra nhiều này. Với long định giới. Đâu về đấy. Chuẩn bị lên top nha. Ai chuẩn bị support nha. Thôi tao đi.
Chà. Được ạ. Ôi giời ơi. Chết luôn. Em cút thôi. Không có nói gì mà tắt xếp em tắt được.
Nghĩa là mày có mỗi mày muốn có tinh trùng mày nói đây có thằng đàn ông hả?
Bài nào mình ba
Đi mẹ có tinh trùng to là cũng bắt tinh trùng to. Con tinh trùng ba con biết là
tôi đừng quay lại trả đau.
Nó cấm rớt mà thằng em bị chết.
Phế lòng tưởng giới.
Đánh đúng bản chất rồi đi.
Phải xin mày.
Đây là lý do bố mình xin ngồi mua cái này.
Như đây bố mày có con đấy lên.
Lên này. Cái cầu to như thế này. Ai nổi chưa?
Ôi giời.
To thế vẫn trượt được. Ê nhìn là cái lúc nó thẳng cả. Chưa.
Con này canh hợp lý với bạn ơi. Con này canh hợp lý với tập đi lên. Canh dễ. Tôi tốt nhiều.
Con này farm lên khó.
Đây bạn ơi. Đây ăn con này chúng ta đi tôi thả lên cho bạn. Tội.
Rồi. Không ra, có tao bảo kê ở đây.
kê cái đi vệ. Mày tôi chết mày.
Vệ thổi.
Chạy trước. À đâu lấy được cái thông biến. Ui giời ơi, cái con vượn này. Cái con vượn là sen này. Cái con vượn sen thì không đi ra.
Chết mẹ ai.
Ui, sen tầng.
ở bên mình
Ui giời ơi, Johnny Đần 303 rồi nó thoát khỏi game. Mày ấy lại đi, sao đấy? Mày sao? Ôi giời ơi, đây là cái support thì cứ đi đâu, support thì cứ đi lên trên và ngày mai thằng này đi đua hay sao ấy. Đánh, tao không đi rồi, đéo đi được hai cái.
ở đâu mẹ
Nghĩ tao cũng họ mà. Cả bố tao.
đấy rồi các con đã đến trong sợ đấy sao tao không phanh được
Rồi luôn. Rồi luôn. Vâng, AD là được fan. Kinh mẹ nhá. Đến đâu ấy?
choáng chúng ấy đi mất
Mày lên cái làm chậm cái muốn đi đến á. Chạy trước. Đấy.
dăm ba chú mẹ đi mấy tiền
Thơm tí nhỉ. Giết cô này có được mấy tiền.
hồi đi cho đi
Tay nó vào đây.
rồi này 90 thì đâu giết rồi rồi này cái cú bắt tay hỏi nhưng mà làm sao mà bắt được anh phía Long chạy thôi chạy rồi rồi này bắt được anh cá thì có
Lên mẹ cái chuyện băng đi. Làm chậm.
tôi để nó rút vào con chú mẹ không đủ tiền
Mẹ mày lên cái đồ. Mẹ thì chả phá.
đi từ phim
Rồi lấy đâu được cái gì nữa.
vô này xuống chỗ nào
Ôi, vẫn chưa được. Ta được phải dứt. Lời. Ôi giời ơi. Anh dưới anh cũng đi luôn. Anh được chụp chứ đâu. Lời. Cái này chụp chứ là lời.
22
Phao từ đấy luôn đấy. Anh đi phao từ đấy luôn đấy. Cái đồ AD kia thì lấy đâu ra đá. Đồ AD kia lấy đâu ra đá. Tim không ai lên. Tí máu rồi. Ôi giời. Tim mẹ chẳng bao giờ đạn nó chẳng được. Mẹ lên máu. Có ai lên đâu. Để mẹ nó lên. Đây. Đấy. Trên tim. Xong ra lên rồi đi lên rồi. Cái lúc tôi dùng đạn thế này tí máu rồi. Xong rồi nhìn xong cái thằng trước mặt tôi cứ máu.
15 trận này đánh được chặt
Kéo chết rồi.
ui rồi bắt xét
Chạy mới điện.
cút ra nó rút ra
Ôi là
đội bạn nó rút ra bạn dừng đá quá mà
đồ gì các thứ luôn. Hay báo.
chưa ba chạy được dừng lại đầu ghi chúng sẽ cho phép quen thì tốt nó bị chạy Z lên châu phải chỉ nhân sắc châu nó tăng châu nó test đặt khai xếp của nó
kéo một chăn thêm đuổi là chăn đuổi.
Okay. So let's continue. So let me continue because so many people asking the question relating to the air resistance. So in case these lines, that is in case free fall motion, no air resistance, you have the straight line. If you have air resistance, the velocity increase until, because when the velocity increase, the air resistance increase, and it increase until it catch the value of G, making the A total is 0. And A total 0, V is constant. V is constant. V constant means you have the horizontal line here. So in this example, I give you the example. It gets the terminal velocity after 4 seconds. But in case you have more air resistance, then object can get the terminal after 3 seconds. So in this case, the terminal velocity is not 12 but 18 is smaller. Somehow here. And if you have more air resistance, you have the lower line. Okay? And more air resistance, you have lower line. Vice versa. If you have less air resistance, means after not terminal here but it's terminal here. So the velocity is increased. Not 20 but maybe 22, 24. So in case less air resistance, then you get the higher value of the terminal velocity. Okay? So look up here. You can compare which object having more air resistance. Okay? This more air resistant. This less air resistant. Less air resistant. So decreasing the air resistance. This direction. Is it clear? And then if you have less air resistance, you have upward. But it never gets this line. Because until this line is no air resistance. Okay? Alright, so we move to the next part. That is so far you consider the one-dimensional motion, right? So now you will consider the general case. Not one-dimensional, but 3 dimensions. 3 dimensions, you have object is moving like around any trajectory, not straight line only. Okay? So in 3 dimensions is the most general case in the reality. And 1 dimension is only one particular case of the 3 dimensions. So now we deal with the general case. considering the motions in 3 dimensions. So to work with the motion in 3 dimensions, in this, to deal with the 3-dimensional motions, we have to see the displacement in the vector form. That is why, firstly, I remind you the vectors and the coordinate system. Okay? So here is the Cartesian coordinates to describe a vectors. So the Cartesian coordinate is always OZ and OY. And then you have a vector. A vector, and how to determine the vectors? So this is a 3-dimension. It's a bit difficult to imagine, but now I will make example with 2-dimension. If 2 dimensions, if the 2 dimensions you have OY, you have OX. Sorry, this pen is not easy to draw. It's so hard. So, OY, OX, okay? So if you have a vector A, so you can resolve this vector along OX by making a perpendicular to OX. And then from here to here is AX, components of this vector along OX. Do you know this from high school? AY is the components of the vector Y, A on OY. In this case, it's a positive and vice versa, you get a negative value. So along OX, you have 1 dimension. Exactly the same you deal with the 1-dimensional motion. And here is 1-dimensional motion, but another components. So in 3 dimensions, you have 3 axes, and you have 3 components. 1 dimension, you have 1 component, x. 2 dimension, you have 2 components, x and y. 3 dimension, you have 3 components, x, y, and z. And the treatment for each component is the same. Okay? That's the idea. So next, you compare the vectors and scalar quantities. So what is a scalar quantity and vector quantities? Scalar quantity, for example, you have the time. The time is scalar quantity. The mass, okay? The mass is always positive. Only 1 value, and the magnitude, no direction, no negative, right? Anything else? Volume. Okay? All the area, scalar quantity. All the distance, always positive. Speed, okay? Speed is a scalar quantity because you care only the magnitude of the velocity. So speed is a scalar quantity. The vector quantity is the force, right? You have the direction. The displacement. You care the direction, right? Go to the left or go to the right, or go up, or go down, or go north, or go west, or go east, south. The displacement have the positive value or negative value. So it has a direction, so vector. So you distinguish scalar and vectors quantities. Scalar quantity is also temperatures, it's only magnitude. Vectors, you care both magnitude plus direction. So we have 2 properties, magnitude and direction. Magnitude 2, but if direction is positive, say the value is plus 2. Magnitude 2, but opposite direction. You got the value is minus 2. Okay? That is the vector. And here I remind some properties of vectors. I think you learned already from high school. So here's just a revision. If two vectors is equally of two vectors. Two vectors is the same equally is they have the same magnitude and pointing in the same direction. Okay? Vector addition. You use triangle rule or parallelogram rule for the addition to vectors. So I have vector A here, vector B. How can I make vector A plus vector B? Okay? So vector B is the same as vector B is a parallel and the same magnitude is a B, right? And then I bring this vector B to the, so this vector is the tails, is a tail and is a tip. I bring the tails of B to the tip of A. I make like this, B. Okay? So vector A plus B, I pointing from the tails of A to the tip of the final one. So I have this one. It's A plus B. Okay? That is a triangle rule. That is two vectors. In case I have many vectors, I do next vector C, vector D, vector E. So I make I put the tails of the next vector to the tip of the last vector, and then I continue. And then the resultant vector is from the beginning to the end. Okay? That is the ending rule. Parallelogram rule in case of two vectors. Vector A here, vector B here. With the parallelogram rule, I don't bring this tail to the tip of A, but I bring this so that they have the same tails, same position. So I bring B to here, so B is here, B here. Okay? So now the summing A plus B is I make the parallelogram rule. Okay? So I point from here to the last one. So here is vector A plus B. So this you already learned from high school, right? That is adding two vectors. Associate law of addition is A plus BC equal to A plus B first and plus C. Negative vectors. Negative vector A of A is a vector that adding to it gets 0. So if you have, I have vector A here. So vector minus A is some vector such that if I adding to them is 0, so it's go back to here. So the next minus A should be this. Okay? So the negative vector having the same magnitude but opposite direction. Clear? Negative vector. Subtracting two vectors. How can we do? How can we do A plus B? A plus B you know already. So now A minus B. How can you do? So first step, you find minus B here, you find the minus B. Minus B is the same magnitude but opposite direction. Okay? So I put the adding between A plus of minus B. Agree? A plus minus B. So minus B here. So minus B here I have to. Minus B. And then A plus minus B I get this one. Okay? So it's very easy. Okay, right? Clear? Alright. Components of a vector and the unit vectors. Components, yeah, I already explained, right? In case of in case of one axis, one-dimensional motions, so I have vector A here. One-dimensional motion, I have one axis and one coordinate system that is OX. So what is the component of vector A along OX? So I project it perpendicular of the tip and perpendicular of the tails to OX. And from here to here is A along OX. Okay? So normally you call X OX is putting the line under the tails of A. You go X like this. And then the distance from here to here is components of vector A on OX, and then I denote it as AX. Similarly, if I have two dimensions, I have one more component that is OY. And then I do similarly. I put here, and then I project vertically perpendicular to OY, and then from here to here is AY. And I say that AY is a component of vector A along OY. And similarly, in three dimensions, I have one more component. And in general, a vector A having three components, and then I can denote it AX, AY, AZ. Now we get the relations between AX, AY, and AZ and A. For example, I have two dimensions to be easy. So I have AX equal to A. For example, I call this angle is alpha. So AX equal to A. A is the magnitude of vector A. Cosine alpha. AY is A multiplied by sine of alpha. This is a relation. And if you know AX and AY, so if you know A and alpha, you can get AX and AY. And vice versa, if you know AX, AY, and how to find A and alpha, right? Then what you do is A squared equal to AX squared plus AY squared, and tan alpha is equal to AY over AX. This is two components. So in three components you have similar. So in this course we only deal the case with two dimensions. But three dimensions you can generalize it. Okay, so these slides also remind that I have that showing vector magnitude, AX squared, AY squared, AZ squared. So this part unit vectors, and this unit echo, I can upload the slide. Okay? So scalar product between two vectors. I have vector A and vector B having the component AX, AY, and AZ, BX, BY, BZ. So the scalar product between these two vectors is AX, BX plus, and this equal to A, B, cosine of the angle between A and B. right? Remember? That is a scalar product. Now, so I have just remind you about the vectors. What you already learned from high school, so I go very fast. Now we move to deal with the motion in 3 dimensions. So, in 3 dimensions, you see the displacement is not one value, but is one vector. One vector. Okay? So, in 3 dimensions, you choose origin, still the same, we choose origin is O here. And for example, you are standing here, M. So the displacement is a vector pointing from the origin. The tail is here and the tip is the zone position. And you notice this R, displacement vector R, at the time T. Okay? At the time T, you are standing here. And then I said that the displacement is determined by the vector R at the time T, and this is my notation. Is it clear, the notation? So, because it is a vector and in 3 dimensions, so we can choose 3-dimensional OX, OY, OZ, right? And then you resolve this vector in 3 components. That is the displacement. So, the same definition as before. What is the velocity? So, you have 3 components of the displacement is x along OX, along Y, along OZ at the time t. I know this xt, yt, and zt. So, xt is behave exactly the same as before we did with the 1-dimensional motion. Alright? So now we define the velocity. Average velocity is, or this instantaneous velocity is the limit of the changing of the displacement with times. For example, at t you are standing here. After some times, for example, you are here. You are here at n. Okay? So here is the time t plus delta t. After delta t second, you are standing here. So your position here is pointing by the vector from the origin to the new place. This vector is a vector position after time t plus delta t. Is it clear? So by definition, average velocity is the final displacement minus the initial displacement divided by time. So that is this vector minus this vector divided by delta t. And this vector minus this vector is equal to this plus opposite. So vector delta r equal to r at t plus delta t minus r at t is what? This and this. So pointing from m to n. So this is vector. This is delta r. Agree? So the direction of delta r is pointing from the first position to the final position. And v is delta r divided by delta t. Delta t is a scalar quantity. So the direction of v is the same direction as delta r. So from m to n is the direction of v. So v having the direction from m to n. Okay? So this way you can find out the vector velocity. And if you project this vector in 3 components, you get v having 3 components, vx, vy, and vz. So then you define vector v is the derivative of the displacement vector over dt. And if you can calculate components by components, then you have v along x equal to dx by dt, vy by dy by dt, vz dz by dt. And this one you have it, met this before in one-dimensional motion, right? If you consider the motion is just along x, then you get v velocity along x is a one-dimensional motion, as you did before. And along y, you get a similar one-dimensional motion. So, in the case of moving with a three-dimensional motion, you resolve along three components, OX, OY, and OZ. And each component is exactly the same as one-dimensional motion. Remember? Okay. Is it clear? So you have one-dimensional motion, you know already. And then now you have three one-dimensional in three components. And then you have Vx, and you have Vy, and Vz. And from the component you can find the V total. For example, two components, you have V equal to square root of Vx squared plus Vy squared. And then you get the velocity. Okay? So, for example, in case of two dimension, you get Vx, you get Vy. So we can find the velocity is the square root of Vx squared plus Vy squared. Agree? It's very simple. And three components, they treat exactly the same one dimension before. All the formula keeping the same. Alright? So, similarly for the acceleration, also the changing in the velocity with times, and then still you have the component Ax is the derivative of Vx over dt, and the second derivative of the displacement along OX. And OX, Y, and Z, they have the same formula. You just change the name of the projection. Is it simple? Okay? So, in three components, they behave exactly the same way, but the different name of the projection components. That's it. Very simple. Similarly as before, now we try to look at example in the simple case. That is a motion in three dimensions but with constant velocity. So in this case, what does it mean constant velocity? So it means that vector v need to be constant. Vector v constant means what does it mean vector v constant?
V equal
What does it mean v vector v constant? Speed is a constant. Speed is a constant. The magnitude is constant. And direction no change. You are not allowed, you are moving with 40 kilometers, right? You are not allowed to go back. That is a constant velocity. Even if you give 40, but acceleration is not allowed. So we need two conditions. Magnitude is the same, direction is the same. No change, anything. That is a constant velocity motion. And then we will see what is the trajectory of the particle. If in three dimensions it's moving with a constant velocity. So, my origin is here. Initially, at the time t0, my position is determined by r0. This is a vector, okay? After t seconds, this is delta t equal to t. At t time t, my position is this vector. So the changing in the displacement delta R is R minus R0. So this vector minus this vector, so is this vector. Agree? And this vector is the same as vector v, because vector v is delta R, delta t. And this is a constant. Constant means it's going, and keeping the same, the direction. So trajectory of the particle is straight line, and along this line, go to forever. Okay? So in three-dimensional space, we still have constant velocity motion. Trajectory is straight line. And in this case, along OX, you have x at the time t equal to x0 plus v t. But before here, you put x here means components of vector v on OX. So can you write similarly if you have a y at the time t equal to Vy and t. Very good, thank you, Vinay. And z, t equal to Vz. Very easy, right? Thank you. It's clear? And even you can generalize to the n dimension, not only 3 but n. N dimension, you need the same. And then you have x1, x2, x3, x4 until xn. You project all. Because later, we will learn more at a higher level. So space not only 3, but you have extra dimensions. When you have 4, 5, 6, 7, who knows? N dimensions. There you have xn. Okay? And exactly the same. For each component, exactly is the same as one-dimensional motion. Okay? Good? So, this is a formula you remember. So, this is a vector form. Vector R is vector R0 plus vector V0 T, a vector, this is a vector form in general case. In components, you have exactly the same as before. X0 plus V0 along y, T plus AX T square over 2, Vx equals to like this. And the homework is you write down yt equal to what? Vy at the time t equal to what? And z t equal to what? V along z t equal to what? Exercise. Write yourself. And then now, if we do the example, considering free-fall motion under gravity and projectile motion in 3 dimensions. In 3 dimensions, okay? In 3 dimensions. So before you already know the one-dimensional motion you consider in a one-dimensional space. And now, I consider the case free-fall motion, but in 3 dimensions. One. Is it the same results or not? Okay? This is a projectile motion. So okay. So I can use this space to deal with the simple case of free-fall motion. So free-fall motion is I have the ground is here, and the object having the mass m is falling down. This direction g. Okay? So I choose the coordinate. I choose the next OX, OY, and OZ is perpendicular to this surface. So x, y, z, x, y, z. Okay. So OZ is like this. OY, OX, OZ is go down, go into the ball and perpendicular to the ball. Okay? Perpendicular to the surface of OX, OY. And the direction is go into. Okay? Clear?
Clear, yeah.
Yeah, like this. Alright? So in this case, in three-dimensional space, x, y, and z, what is the acceleration along OX? Equal to? Z is a vector. If you project on OX, is what? Do you know how to project it? I have this component. Z is a vector. How about the projection of this vector along the perpendicular? 0, right? Because the tip and the tail is the same. So AX equal to 0. Agree? AY equal to G. Good. How about AZ? 0. Good. That is the acceleration in three components. So, by knowing acceleration, how can I determine the velocity? Initially, for example, it's at rest. Vx after time t equal to 0. 0. At 0 forever. So which means that the object doesn't move along OX. Agree? Because it's just falling this direction. Is it okay? Always 0 means it's flowing like this. It doesn't move along OX. X after time t equal to 0 plus 0 plus 0. So plus 0 always. Trajectory is along y. V, y, t equal to 0 plus g, t. Alright? And y after time t equal to 0 plus 0 plus g t squared over 2. Okay? So exactly the same in one-dimensional motion along y. Because that is the direction of motion. V, z after time t equal to 0. Z after time 0 is 0 always. So means that it doesn't move along OX, doesn't move along OY, OZ, and only moving along OY. And then you have exactly the equation as in one-dimensional motion. But we just change the name, it doesn't matter. Okay? So for example, if you want to calculate the time falling from here to here, the height is 8. What is the time? You plug to here, right? You plug to here y equal to 8, and then you can get t equal to 8 over g. Okay? So then I have free-form motion, but I consider in the case of three-dimensional motion. It doesn't matter. So in all the case, you can consider all the motion in three-dimensional points of view. That is the most general case. And then the results doesn't change. It doesn't matter. You don't care if it is one-dimensional motion or two or three-dimensional. You just use a vector. It's always one. Okay? Now, we make another example, that is the projectile motion. So what is the projectile motion? projectile motion. For example, I have two components, a y, a x. Initially, my velocity v0 is making an angle with a x alpha. So this line is the trajectory of the objects. Okay? I neglect the air resistance. So in this case, acceleration is exactly the same as acceleration is g. Okay? Acceleration is g. And then in this case, I still treat with the three-dimensional analysis. So 3, OX, OY, and OZ is perpendicular to this. Okay? So in this case, G is vertically downward like this, on this plane. So we do similarly as before. Tell me, the component AX along OX equal to 0. Good. Y equal to? Very good. Minus because I am choosing going up or y. And G is going down, opposite direction. That is why AY is minus G. But if some of you choose Y going down, then you will have acceleration is plus G. It doesn't matter. Okay? The way you choose a coordinate, you can choose whatever you want. It will not affect the results. You try yourself. But in this case, a y minus g. But some of you curious to do a y going down, it doesn't matter. Okay? Check it at home. But now we deal with this case. A y and a, how about a z? 0. So if they do the experiments, I go this initially velocity 50 meters per second along OX. Here is 30, along OY is 40. So after some times, my velocity along OX is still 30, but the velocity along OY is 30. It decreases and go next, this T30, 20, this 30, 10. So you see that? And here is a 0 along OY. So you see that the V along OY is decreasing. And V along OX is constant. And now this period, still Vx along OX is horizontal. It's a 30, 30, all the way constant. But the V along OY now is going down and increasing the value, the speed, opposite direction. So it's going down. And then now we use a formula to explain this. This is an observation. The plot here is an observation. Now we explain this by formula. So we have AX0. So how can you get the V along OX at the time t equal to V0 cos alpha plus 0. So it doesn't depend on time. So this is constant. And the value is 30 meters per second. And it's constant forever, right? And as you see here, okay, it's correct, reasonable. Good. And how about V, Y at the time t equal to V0 sine alpha plus AT. But A is minus G, so minus GT. So it's decreasing because you have minus sign here. Right? If T increase, so V decrease. And then until it gets 0 value. When is 0 value? 0 when T equal to V sine theta divided by G. So we can calculate the time here to get the V, Y equal to 0. Okay? So, and how about X and Y? And how about Z? VZ of T equal to 0. 0 forever. So here, 0 forever means you only have two-dimensional motion. You don't care OZ. Because the object doesn't move along OZ. Okay? Just this in the paper. So how about X after time T? Equal to x0. x0 is 0 plus v0t. So v0 cos alpha t a0. Y plus 0 is v0 sine alpha t minus gt squared over 2. So the shape is a parabola with negative values, slope like this. And x is a straight line. Okay? Alright. Is okay? So at home we do this exercise, and you get I already give you the results, and you derive by yourself at home. Okay? Yeah, this time is over. So I still have one more thing to say, is relative motion. Relative motion is, you have, as I explained from the beginning, the motion is relative. So I'm moving with respect to you, but not with respect to another. So I have three frames. Frame 1, me. Frame 2 is I'm moving with respect to her, right? And then her is moving with the frame, another frame. And then I say that the velocity of object 1 comparing to the object 3 will be equal to vector v2 plus v2, 3. So this, you keep this in mind, relative formula, to consider the relative motion. For example, we are sitting on the train. So my velocity with respect to the ground equal to my velocity with respect to the train plus the train with respect to the ground. Okay? This vector sum of the vector. So the vector you know already, and then you just make the vector sum. So I will give you the exercise to do this in the book, and also, and we stop here. Sorry, I'm late 3 minutes. Because of the technician problem from the beginning. So thank you very much for your attention.